Okay, so we just read about the next problem about this population in a southern city. And the first thing it told us is that it followed the law, the exponential law, right? Okay, so since it is an exponential law and we're talking about a population, then it's automatically assumed to be an exponential growth or an exponential decay model. Now, regardless of which one it is, I'm going to write our generic formula down. Now, some of you may be going, well, how do I know if it's a growth or a decay model? Well, here's the thing. They told us if the population doubles. So if it's doubling, I'm dealing with a growth model. Agreed? Okay, so here's the thing. They said the population doubled in size over 28 months, and the current population is 20,000. They want to know what the population is going to be 2 years from now. Well, here's the deal. If they're asking me what the population is going to be 2 years from now, then I guess I need to know the specific formula, don't I? All they gave me was the generic. Now I need the specific. Agreed? Okay, so here's the deal. What are the two things I need to know in order to come up with the specific formula? That's right. If you remember from the last one, I need P sub 0, which is the initial amount, and I need K, which is the rate. Did they give me the initial amount? Yeah, they did. They told me the initial amount was 20,000. Agreed? Okay. They didn't give me K, so now I need to find K, don't I? So, in order to find K, what other information did they give me? That's right, they said the population doubled in size over 28 months. So, let's see. Population doubled, which means, yeah, that means the population is going to be 40,000, isn't it? And the time it took to double was 28 months. Agreed? All right, so that gives me an idea of how to set things up so I can find K. So, at the end of 28 months, we had 40,000, didn't we? So that means my 40,000 is the ending. My initial amount, they told me, was 20,000 people. E is raised to the, I'm looking for K, and the time was 28 months. Cool? Okay, so start solving. Divide both sides by 20,000, which gives me 2, is equal to E to the 28K. And you got to get rid of that E, which means you have to take the, excellent, natural log. So I have the natural log of 2 equaling 28K. And then that tells me my rate is the natural log of 2 divided by 28. Just like the last problem, I do not want a decimal here because it says do not round until the final answer. So if I round too soon, I am not going to get as exact an answer as we're looking for. So now, my specific formula. I've got the two pieces to my puzzle. I've got my initial amount, which was 20,000 people. I have got my rate, which is the natural log of 2, the whole thing divided by 28. Good? Okay, now I can answer whatever question they give me. And their question is, what's the population 2 years from now? Okay, something we have to be extremely aware of. Do you notice the time they gave us was in months? Well, if they're saying 2 years, yeah, I have to convert that to 24 months. Which means when I plug this in, P is going to equal 20,000 times E, and now it's being raised to the 24 times the natural log of 2 over 28. Okay, they want us to round to the nearest whole number. You get your calculator, I'll get my calculator. You have to be very careful how you punch these things in. And me personally, I don't punch this in all at the same time in my calculator, because if I forget a parenthesis, I'm going to get the wrong answer. So, just saying, be very aware. When I did this work, I ended up with this population in this southern city being approximately 36,229 people. Good? Okay. Hang in there. Got another example.